Welcome back to Geomatics. This is question 7 of the Nov-Dec 2023 Wassce past question. This is a plane geometry question, and it says that a chord AB of length 8 centimeters is drawn in a circle center O. If the circle has radius of 7.5 centimeters, find correct one decimal place the angle the chord subtends at center O, then B, length of the minor arc formed by the chord, and then C, the area of the major sector AOB, and II triangle AOB, the area of triangle AOB, and the area of the major segment formed by the chord, taking pi to be 22/7. You need to draw in these types of questions. Well, the first thing to do is to draw. So I'm going to use a free hand. You can use your compass and a pencil to make it nicer. I'm going to use a free hand. Okay, so this is my circle with center. It says a chord AB of length is drawn in a circle center O. That means that this circle has a center of O. And says that a chord AB is drawn. A chord is a line that touches the circumference. Two circumferences, okay, or two parts of the circumference. That means from this side to this side. Straight line that touches it. The two. It's a chord. So this line called AB. So I'll label this A and B. And it says that the length, chord of length 8 centimeters. So it means A to B is what? 8 centimeters. So you could say AB length is 8 centimeters. We have that in mind. It says that if the circle has a radius of 7.5 centimeters, we can find correct one decimal place the angle the chord subtends at center O. So this chord is subtends an angle, means that when you extend this end of the chord to the center and you extend this other end of the chord to the center, the angle that is formed here, theta, is the angle subtended by the chord. Let's also take note that according to the circle theorem, a line that is moving from the center to a chord is perpendicular, and it divides the chord into two equal parts. So now let's take out that triangle and let's not forget the line from the center that touches a chord is perpendicular. That means it forms an angle of 90, and it divides the chord into two equal parts. Let's not forget that the total distance is what? 8 centimeters. If this line is divided into two, this side becomes 4, this side becomes 4. And this theta which you are looking for, you can see it becomes theta 1 and theta 2. So we can say that theta is equal to theta 1 plus theta 2. That means you add the two angles, it gives you the bigger angle here. Okay, and that's what we are looking for. So looking at this, we have a right angle triangle. The question is interested in us finding, and it says that this is 7.5. It was given in the question that is the radius from the center to any part of the circumference is the radius. It's 7.5. That's 7.5. So this is an isosceles right. Okay, sorry, this is an isosceles triangle, and this is 7.5, this is 4. Can we not find theta using the trigonometric ratios? Since we know this angle, we can say that theta 2, which trig ratio do we use? We can use one that involves the opposite and the hypotenuse, and that is sine theta 2 is equal to opposite of the angle theta, which is 4, over hypotenuse, which is 7.5. So we can see that theta 2 is equal to the sine inverse of the result 4 over 7.5. So I'll simply use a calculator to do it straight away. And that is giving me 32.23 0 to 4 decimal places. Okay, so that is theta 2. Let's find theta 1. Theta 1, or we say sine theta 1, is also going to give us 4. That is opposite over hypotenuse, because this is the hypotenuse, over 7.5. So we know that theta 1 is also going to give us the same value, sine inverse of 4 over 7.5. It is giving us the same value. Okay, so we can find our theta now to be theta 1 plus theta 2, which is equal to 32.2310 plus 32.2310. It is giving us 64.462. So we've been able to find the first part of the question, which says the angle the chord subtends at center O. B says the length of the minor chord formed by the chord. Sorry, the length of the minor arc. This is the minor arc formed by this chord. So to find that, it is the angle over this angle over the total angle, 360, total angle in a circle, multiplying the circumference, which is what, 2 pi r, which means that we're going to get 64.462 over 360 times 2 times 22 over 7 times 7.5, which was given. So you can type everything on the calculator and then you just get the result. It's 8.441 5 to 4 decimal places. But the question says to find correct 1 decimal place. So it means that this answer we got here should have been taken to 64.5. Okay, but I'm going to still use the longer value, although the question demanded 1 decimal place, and that's what I've provided. But to make my solution more accurate, I use the decimal. So taking this also to 1 decimal place becomes 8.4. And it's also in centimeters. This is an angle, and this is in centimeters. Now let's go to the C, to CI. To find the area of the major sector AOB, you need to find the angle that is from here to there. Since we know theta, we can find that angle by saying 360 degrees minus that angle which we found to be 64.462 degrees, which is going to give us 295.538. Okay, and we are also going to use the same formula, theta over 360, because you are finding the area, use times pi r squared. So we continue and we see that we're going to get theta is now this angle we found. So it becomes 295.538 all over 360 times 5, which was giving us 22 over 7, times r, which is still giving us 7.5 squared by r squared. Okay, so we type this on the calculator and we get our final answer, and that gives us 145.130 to 4 decimal places. 130. Okay, but the question says to take it to 1 decimal place. Let's not forget to find correct 1 decimal place. Anything you're finding should be in 1 decimal place. So it is equal to 145.1 to 1 decimal place. But is it a length? It's an area. So what is the unit? So it should come 145.1 centimeters squared. Since it's an area, 1 decimal place. So that is the area of the major sector AOB. How do you find the area of the triangle AOB? There's a formula. Find the area of the triangle. And that formula, that is II, is given by half r squared sine theta, where theta is the angle here. I'm using this one. So the angle inside here formed at the center. So r is going to be my radius. So it's going to be very simple. We're just going to have 1/2 times r. What is r? The radius. 7.5 squared sine, and what is the angle? 64.462 degrees. So that is it. So also in 1 decimal place, let's not forget that. So that gives us 25.3771 is also an area. So to 1 decimal place, I'll say 25.4 centimeters squared, and I'll say 1 decimal place. Now let's deal with the last part. It says find the area of the major segment formed by the chord. So this chord divides a circle into 2 parts, the upper parts and the lower parts. So we need to find the area of the upper part. How do we go about it? So it will say area of major segment is equal to, see, we are looking for the area of this whole thing. That means that if you can find the area of the triangle and we find the area of the bigger sector, which you've already done, that is going to give us the area of the major segment. So we are going to add the area of the triangle plus the area of the bigger or the major sector, which we found here. So we add this and this together. So area of triangle AOB plus area of major sector AOB, and that is going to give us the area of the triangle was 25.3771 plus the area of the major sector, which you got to be 145.1303. So I'm using the longer values and I'll approximate it finally to 1 decimal place. That is giving us 170.5074 to 1 decimal place. I'm going to get 170.5, but so if this is to 1 decimal place, it should be what? 170. Check after the first decimal and see if the number could add 1 to this. Since it is less than 5, becomes 170.5. See, but that's an area, so centimeters squared. Forgive the C being big, okay? That is to 1 decimal place. And bingo, we are done.